Hello there, our wonderful viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel is specially created for you and I to come together to tackle mathematics and demystify the age-long phobia associated with this all-important subject, one topic at a time. Thanks for staying tuned. Today, we are looking at a deeper aspect of the topic, which is product rule. As I said in previous videos, differential calculus is a very broad topic that needs to be dealt with extensively in different forms. So today, we are going deep into product rule. What is product rule really? In our very first video, or the second one here about, I did say that to differentiate, all you need to do is to make sure that each term is written in terms of indices and again separated from others by plus and or minus. But what happens when you have products? You have the option of either expanding the product and then solving differently, or you adopt the concept of the product rule, as the case might be. So let's see how this product rule operates. To start with, if y equals to uv, this is u times v, where u and v respectively are functions of x individually, then dy dx can be written as u dv dx plus v du dx. To make sense of the application of this formula, let's take some questions. So question 1, find dy dx. If y is equals to, we have 4x minus 5 times 3x plus 7. Okay, we have 4x minus 5 times 3x plus 7. This is clearly a product. As I said earlier on, you have the choice of either expanding or algebraic expansion before solving. But that might not always work in all cases. Hence, there's need for us to solve using the product rule. Now, for product rule, you need to identify your u and v. Because of the property of commutativity of multiplication, we can say this is my u, this is my v, or I can say this is my v and this is my u. So if I start by saying the first bracket is v and the second one is my, u, and the second one is my v, adopting dy dx for product rule, which is u dv dx plus v du dx. Now what this means is, write u down the way it came in the question. So you have 4s minus 5. This is the product rule. Multiplied by dv dx. It means differentiate v with respect to s. And v is 3x plus 7. So differentiating 3x plus 7 simply results in 3. Hence, this is u and this is dv dx. The other part, we switch roles this time around. I write v down first. So I'm going to have 3x plus 7. That is v. Now differentiate u this time around. U being 4x minus 5. So differentiating 4x minus 5, I'm going to have just 4. And as a matter of fact, I am done differentiating at this level. What follows is simply algebra, expansion of algebraic terms, whereby I open up the bracket and that is 12x minus 15, then plus 12x plus 28. Collecting like terms, 12x plus 12x is 24x, and minus 15 plus 28 is plus 13. And that is pretty much how to differentiate the product. It's that simple. Again, we have your u, we have your v to start with. So adopting the formula u dv dx plus v du dx, you write u down untouched, differentiate the partner, which is v. Differentiating 3x plus 7 results in 3. Then we switch roles after the plus by this time around writing v down untouched, which is 3x plus 7, and then differentiating u, which is 4x minus 5, which gives 4. After this, as I said, this singular step is actually the differentiation part of it. What follows is algebraic expansion. Just to simplify for that. So 3 by 4x is straight x. 3 by minus 5 is minus 15. Here, 4 by 3 is 12x. 4 by 7 is 28. And at that point, I simply collect like times. 12x plus 12x is 24x. And 28 minus 15 is simply 13. Okay, let's take our second example, still on the product rule. This time around, we have y equals 2x cubed sine x minus 5x squared cos x. Now this is a tricky one because we have double product here. We have 2x cubed sine x as a product, then minus 5x squared cos x, another product. We have double product there, separated by minus. So how do we play this out? Okay, so we're having like a u on one hand there and v, also u and then v. So carefully, what you need to do in summary is to apply the product through here on its own, minus apply another product through here again, and simply subtract. So let's go. So we have dy dx equals, mentally applying the formula, u here is 2x cubed, differentiate v is cos x. That's the first part. Now, plus, switching rows, v now is sine x times, differentiating the u now, I'm going to have 6x squared. So this is u dv dx plus v du dx for the first term. Now, minus, once you have minus, introduce a parenthesis to avoid a costly mistake. So repeat the process here. Now, this time around, this is my u, this is my v. So, again, apply the formula, u is what? 5x squared. Differentiate cos, which is the v. That gives us minus sine x. So this is my u dv dx. Let me use dot to avoid the confusion of x and times. So, on the other hand, plus v this time around is cos x. And what is du? 10x. Okay. So, I have double product rule in a single question. So, I'm having here u, which is 2x cubed, differentiate v, which is going to be cos x. Then plus, we switch rows this time around, v sine x times du, that is 6x squared. So this is product rule for the first part. Then after the minus, I have another product rule to be applied here. Okay. So simplifying for that, I'm going to have 2x cubed cos x plus 6x squared sine x. Now, carefully open the bracket here. I'm having minus 5x squared sine x there. When I open the bracket, it's going to become plus 5x squared sine x. Then minus times plus there, minus 10x cos x. And I don't think there's any like terms here whatsoever. No like terms whatsoever. Meaning our answer is that. So that is the y dx for this question, which I believe you found a bit interesting, even though quite lengthy, but it's quite interesting. And that takes us to the very last example. And the unique thing about this last example is that it's combining function on function with product rule. So let's see how that goes. We have a y is equal to 3 minus 4x to the power of 7, then 2x plus 3 to the power of 6. Okay, fantastic. This in its own is a function of function because of the power. And now we are having a product of it. So let's see how to merge function of function and product rule. And we are going to bring in handy, we're going to have in handy the last video, the concept of differentiating function of function using the multiple choice or objective exam approach. Okay, so this is my u, Here's my v. So the entire 3 minus 4x to the power of 7 is u on one hand, and 2x plus 3 to the power of 6 is v on the other hand. Bear in mind that we have a function of function problem here, matched with product rule. Okay, so dy dx, the rule does not change, being the product, is u. Please pay attention here. 3 minus 4x to the power of 7. That is my u. Differentiating v. This is where our internal and external differentiation comes in. So differentiating v. So we are first going to do the internal, which is 2. And then the external, that will be 6 bracket. Then we have what here? 5. So here I'm having product rule. This is u. Then everything here is dv dx. Now, plus v. V is going to be now 2x plus 3 to the power of 6. That's v. Now, differentiating u, don't forget, u is the entire 3 minus 4x to the power of 7. So, differentiating u, I have to look at internal first. That's going to become minus 4. That's internal. Now, the external will give me 7 times this raised to power 6. It's a bit cumbersome, I know, but it's quite straightforward really. So after doing that, we can now simplify further. This is actually 12. We have 3 minus 4x to the power of 7. Now fill in the bracket, which is in this case 2x plus 3 to the power of 5. That is this. Then here it's going to become minus, because plus times minus 4 times 7 is minus 28. Then we have 2x plus 3 to the power of 6. Then fill in the bracket here, which is this time around 3 minus 4x to the power of 6. And that does it. Quite straightforward really, but it can be a bit tricky for a first timer. So all you need to do is to identify your u and your v. And bear in mind, very importantly, that you are having a function of function in this product. So that's going to be the end of our class for today, which has been the product rule. So in summary, for product rule, we have y being equals to u and v, where u and v individually are both functions of x. Dy dx will simply be writing u down untouched and differentiating v. That's the product on one hand, plus you now switch rows this time around. Write v down untouched and differentiate u. So the resulting differential that you have, you simplify it by algebraic expansion and you have your answer. If you have any issue whatsoever along the line, you have the controls. All you need to do is to pause or revert to any part that you're having issues with. And I believe you're going to have it as fun as I expect. If you find today's class as interesting and exciting as I did, don't forget to like, share, subscribe, and most importantly, stay tuned for the next. Thanks and God bless.